Okay, so there was a question on working out some problems.
You guys got a Sasquatch? Is that another recording?
Shh. You might just hear Henry, who's really annoying. So there were some questions about sum and difference identities. This one problem in particular, and we've actually seen a question like this, exactly like this, on a test a couple tests ago. It said, it gave us an equation on the test, and the equation was something like this. I might mess up the numbers, but it was something like 2 sine of 3x plus 4 cosine of 3x. It gave us that function. But then the directions were write a function that only uses the sine function and has coefficients, real value coefficients, but you don't use the cosine function at all. In other words, you're not going to have something in the function that has like a cosine of x or a cosine of 3x. So the directions on the test said, I want to write f of x in this form. A sine of b x plus c. So I want to see if I can write f of x in that form. Now, if we remember this, the way that we did this on the test is we just took this original f of x here, we graphed the function on our calculator, we found out the amplitude using the graphing calculator, we found out the period, again using the graphing calculator, and we found out the horizontal shift, again using the graphing calculator, and then we wrote the equation for f of x. So what I want to do is I want to use this right here, and I actually want to apply the sum and difference identities of the chapter and write the function without using my calculator at all. So the first thing I'm going to do here is I'm just going to distribute the b value through the parentheses there, so I wind up with that. Okay, now I'm going to use the angle sum formula for sine, and I'm going to rewrite that expression. So now I'm recalling that one of my new identities is that if I have the sine of alpha plus beta, that equals the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. That's one of my new identities right there. So now I'm going to apply that identity to that expression right there, where my alpha here is really like bx, and my beta is really like bc. So I'm just going to write out what a sine of bx plus bc would be if I used this angle sum identity for sine. So that would be, I'm going to go to a fresh slide here. So a sine of bx plus bc. So that equals a, parentheses, that's going to be sine of bx cosine bc plus cosine of bx sine of bc. So I just use the angle addition sine formula on identity on that piece right there. And now I'm just going to distribute the a through the parentheses, and I'm just going to kind of reorganize the terms. So I'm going to write this as a cosine of bc sine of bx. So I'm just interchanging these two pieces here. Multiplication is commutative, so I'm just reordering the terms. Plus a sine of bc cosine of bx. Now remember, I want that to be the same as the problem on the previous slide, which was, I want that to be the same as 2 sine of 3x plus 4 cosine of 3x. So now I'm just going to kind of match up the pieces of the formula here. So if I look at the formula carefully, this sine of 3x has to be the same as this sine of bx. And this cosine of 3x has to be the same as that cosine of bx. So that means that the only way that that would be true is if b is 3. Because if b was any other value, then it just wouldn't match up. The two expressions wouldn't be the same. So that's a sine of bx. That's a sine of 3x. The only way that can be the same is if b is 3. So b's got to be 3. Now, this 2 has to be equal to a cosine of bc. Because remember, b and c are just real numbers. And so is a. So a times the cosine of bc, that's just going to be a real number. What real number is that going to equal? That's going to equal 2. So a times the cosine of bc, that has to equal 2. And a sine of bc has to equal 4. So I'm going to use those two equations. I essentially have a system of equations, and I'm going to use those two equations to solve for a and b. So I'll write those equations here. I've got 2 equals a cosine of bc, but I know that b now is 3. And I know that 4 equals a sine of 3c. So now I'm going to get a little bit tricky, and I'm going to use the trig identity sine squared theta plus cosine squared theta equals 1, but I have to be tricky in how I combine these equations together. So now that I've got these two equations, I'm going to square both sides of both equations. Now the reason I'm doing this is because I know that it's going to help me. So I'm kind of applying a little bit of the trick here. I know this is going to work because I've seen this work before. So this is kind of the ingenuity step that was probably pretty hard if you were trying to do this on your homework last night. So if I square both sides, I get 4 equals a squared cosine squared of 3c. And if I square both sides of the other equation, I get 16 equals a squared sine squared of 3c. So now I'm going to add these equations together. I'm going to add the left-hand sides together, and I'm going to add the right-hand sides together. So what does that give me? That gives me 20 equals a squared cosine squared of 3c plus a squared sine squared of 3c. So I just took the left-hand sides and added them together, and then I did the same with the right-hand sides. So if I add the two left-hand sides together, that has to be the same as if I add the two right-hand sides together. But now I can actually solve this equation for a squared, because if I factor out an a squared, I'm left with cosine squared of 3c plus the sine squared of 3c. But we know that the cosine squared of 3c plus the sine squared of 3c, we know that that's 1, because that's our original Pythagorean identity. So really, I can conclude that 20 equals a squared, so the square root of 20 must be my a value. So I've solved for b, I've solved for a, and now all that's left is to solve for c. And so I can use either of these two equations. I'm going to use the equation 2 equals a cosine of 3c. So 2 equals a cosine of 3c was one of my equations, but I know now that a is the square root of 20. So now I've got to solve this equation for c. So I'm going to divide both sides by root 20. I get 2 over root 20 equals the cosine of 3c. I'm going to take the cosine inverse of both sides. So I get the cosine inverse of 2 over root 20 equals 3c. So if I divide both sides by 3, that makes c 1/3 the cosine inverse of 2 root 20. So now I can fully answer my question here. My original function was 2 cosine of 3x plus 4 sine of 3x. I know that that is going to equal root 20 sine of 3x plus 1/3 the cosine inverse of 2 over root 20.
Will a question of this amplitude